Hi, welcome. This is the linear algebra, fifth session on dual spaces. We are going to talk about adjoints today. The reference is an article of mine. You have to send a request to the email ID, this email ID. If you send to any other email ID, I will not respond. Okay. So today we want to talk about adjoints. See, let us just look at a very general principle. Suppose x and y are sets, okay, and suppose there is a map phi from x to y, okay, and suppose let us look at f is a function from to r. It could even be to z, right? So let us look at all functions from y to r and all functions from x to r. Suppose I have, let me call it a g. Suppose I have a function g from y to r, then I have natural function, okay, natural function, okay, which is which is defined as g composite phi. So g composite phi will be this function. I call this as f. Okay, this is usually called pullback. Okay, so I have this is x, this is y, this is r, so this is my g, this is my phi. So start with any x, map it to phi of x and map it to g of phi of x. Okay, so you are pulling back functions. So I have a phi star, which is a function from f of yr to f of xr. Do you understand this? From this, okay, you know this is a vector space, this is also vector space. Okay, what I have now, x and y are just sets, okay, then I have some map, this is given, okay, then if g is any function from y to r, I can pull it back to get a function from x to r, namely define f to be g composite phi. Okay, so pause, review and proceed. This is very important. Once you understand, all these kind of dual construction, algebra, adjoints, etc. are much easier to understand. That's why I just want to start with the general principle. Now let's start. Suppose I have a linear map T from V to W, where V and W are vector spaces, and this is linear, and suppose G is a linear functional. As usual, I am assuming they are a vector space over R. It could be over any field also. Okay, then I have a pullback. Okay, so I have T star of G, by definition is G composite T. That is going to be a function from V to R. Now notice that T star of G will be linear map. This is linear because it is a composite of two linear maps. You understand that? Okay, that is what it is. That's it. Okay, so what have we done? We just applied the same thing, whatever we did earlier, except y, v and w are special. They are not just sets, they are linear vector spaces, and G is not any map from W to R, it is a linear map. Then I can pull back this G via T. Okay, I am pull back G via T to get G composite T, which is what we call a T star of G. You understand that? So what do you think I have done? So I am looking at all linear maps from W to R, which is nothing other than W star. Okay, so I get a map from linear map from V to R, which is nothing other than V star, and that is my phi star. That is, give a G and I send it to F, where F is T star. Okay, where this is T star of G, which is by definition G composite T. right? So I have a map T star from W star to V star. Okay, what is T star? You give me a map G. Therefore, what is G? G is in W star, which is same as saying G is a map from W to R, which is a linear map. Then T star of G belongs to V star. That means T star of G must be a linear map from V to R. What is that linear map? T star of G is G composite T. Okay. Take some time. Pause, review, proceed. Once you understand this, you're clear. Again, look at this. This is my V. This is my W. And from here I have G, which is to R. These are all linear. And this is my T, linear. And this is linear. Then by composing, I get a map F. Okay. That is, go by from V to W by T and from W to R by G. That is, therefore I get G composite T. Okay. Just don't try to learn. Just look at the picture in mind and go through this. Okay. So the question I want to ask is whether T star, this is a map from where to where? W star to V star. Right. But notice that this is a vector space. This is also a vector space. Therefore I can ask, question is T star linear? You understand the question? Right? Right? Okay. The answer is yes. Let us just check. So what is T star of? Let us say G1 plus G2. Okay, let it G1. G2 belong to W2 star. Then this by definition is G1 plus G2. Right? This composite T. This is by definition. Right? Now T star of the where should it be? This should be in V star. That means T star of G1 plus G2 must act on a vector V. I have to tell you what is this. It must be a number. But this is by definition G1 plus G2, okay, acting on T of V. This is our definition. Do you understand that? What is T star of G? T star of G acting on V is G acting on TV, right? G composite T is G acting on TV, right? Therefore this is right. But what do I know? This TV is a vector in W. G1 plus G2, G1, G2 are in W star. They are linear functions to R. Therefore, how did I define the addition here? That is G1 of TV plus G2 of TV. But this is nothing other than G1 composite T acting on V plus G2 composite T acting on V. You understand? But this is nothing other than T star of G1 acting on V plus T star of G2 acting on V. But that is T star of, now what are T star of G1? That is in V star, and T star of G2, where is it? In V star. And how is the addition defined? T star of G1 plus T star of G2 acting on V is T star of G1 acting on V plus T star of, therefore this is T star of G1 plus T star of G2 acting on V. This is true for all V. Therefore as linear maps, this is equal to this. That is T star of G1 plus G2 is T star of G1 plus T star of G2. Okay, please, again my request to you is every time you go back to the definition. Many of you have a problem because you manipulate symbols. Okay, do not. Every time there is something is defined, T star of G1 plus G2, what is the meaning? And T star of G1 plus T star of G2, what is the meaning? What is the addition? T star of G1 plus T star. Everywhere you try to understand and go through it. Once you are done once, then you will be happy. Okay? Don't simply manipulate symbols and go through it, then you will never be sure about what you are doing. Concepts will never be clear. And similarly, just to try it out, okay, you verify T star of, okay, some, let's say alpha times G is alpha T star of G. Okay, maybe I will do that so that you become more comfortable. Okay, that means these two maps are equal. That means give me any in V, I have to check whether T star of alpha G, where does this belong to? This belong to V star, therefore this one acting on V. See, I am writing all these things, don't get confused. T star of G, this one acting on V. I have to check whether they are equal. But what is this by definition? This is by definition alpha G, okay, composite T of V, right? This is alpha G composite T acting on V, but that is alpha G acting on V, right? But what is this? This is again alpha T star of G acting on V. Okay, alpha T star, how do I define? Again look at, if F is in V star, how does alpha V belong to? Alpha V is by definition alpha times FV. That's what I am doing. Alpha times T star of GB. Do you understand this? Right? But this T star of GB is nothing else than G composite T of V. Okay, but anyway, let us keep it at this. Right? Now come back. Alpha G composite T of V is this. T star of alpha G equal to alpha G of TV. Right? But this is, now what is alpha G TV? That is again alpha times GB, G of TV. But this is alpha times T star of G. Okay? V. So these two are equal. Therefore T star of alpha G equal to alpha T star of G. Okay? Therefore T star from W star to V star is linear. Take your time, make sure that you follow and verify. Okay, these are the things, just check once in a while, at least once, and every time, as I keep saying, ask whenever you write the symbol, what is its meaning, if it's a map T star of G, where should it act, etc. Okay, keep on asking such questions and follow, then you will find it easier. Many times these are done just manipulation of symbols. That's why students are very uncomfortable with these notions. They are not very comfortable. Okay, if you go through these things as I have done, you should not have any difficulty. Let us look at some simple example. Okay, let us look at an example. Okay, let us look at V equal to R2. Okay, and W equal to, let us say, R3, and my map T, okay, is from R to V to W, that is T of UV is, let me write a very easy one, maybe UV and U plus V. I chose a simple one. Okay, just let's look at it. Okay, then what I want to know, what is T star of from W star to V star. You understand? So you give me a G in W star, then I have to tell you T star of G must be a linear map from R2 to R. This is what I have to find out, right? Now G is from W to R, that is G is a linear map from R3 to R. Then we know that anything is of the form G of XYZ is of the form AX plus BY plus CZ. There exists unique ABC such that this is true for all XYZ. Okay, in R3. Right? This we had already seen in the first session. Do you understand that? Therefore, let us look at it. Therefore, T star of G, this must be, where should it act? Remember, it should act on UV. Okay, this must be a linear map from R2 to R, that is V to R. Right? Therefore, you give me a UV in R2, then I have to tell you what is its UV. Okay, this by definition is G acting on T of UV. And what is T of UV? G acting on T of UV. What is T of UV? T of UV is u v u plus v. And what is g of xyz? That is au plus bv plus c times u plus v. Right? Now remember, this should be a linear map, therefore I have to tell you only what happens to u and v. Let us understand. So that is going to be a plus c times u plus b times c times v. You understand that? Therefore it is of the form some alpha u plus beta v, where alpha is a plus c, beta is b plus c. Right? Therefore T star of G, okay, acting on UV is this map, alpha u plus beta v, where alpha is a plus c and beta is b plus c. I hope I did not goof anywhere. Just go through it. Yeah, just to make sure, let us understand what is the matrix of T with respect to standard basis. R2 and R3. So where does T, what is T of U1? Okay, T of U1 is, U is going to be 1 0 1, that is E1 plus E3, therefore that comes as a column, right? And what is T of E2? That you can see 0 1 1. Therefore matrix of T it has to be what kind of matrix? It should be 3 by 2 matrix. Therefore it is going to be 1 0 1 and 0 1 1. Is that clear? Again this is going to be, okay, E1 plus E3 in R3. Okay, this E1 is not different from this E1, right? This is 1 comma 0, whereas this is 1 comma 0 0 and 0 0 0 1, etc. T of E2 is going to be E2 plus E3 in R3. That's why I wrote it. You understood that? Now I want to find out matrix of T star. And T star is a map from where to where? From W star to B star, which is, this is 3 dimension and this is 2 dimension. Therefore it should be a matrix of size 2 cross 3. Let us find out. Okay, there are 2 ways of doing. Let us look at that. Okay, just to make sure. Okay, pause, review, proceed. Yeah, right. So let us try to find out. Okay, now W is R3, right? And the standard base is again E1, E2, E3. Notice that this is in R3 vectors. Okay, I hope you don't get confused, right? When I write E1, E2, E3 in R3, that means it is 1 0 0 0 1 0 0 0 1, etc. Okay, and I am also use E1, E2 for R2. Maybe I will use U1, U2, or let us say something. What do I do? Okay, epsilon 1, epsilon 2 for R2. Okay, so that we will not get confused. Okay, now what is the dual basis? So when I want matrix of T star, what should I do? I should look at the, with respect to the dual basis of V star and W star, or if you want W star and V star, because T star is from W star to V star. You understand that? So what is the dual basis? We know dual basis F1, F2, F3 and Fi is the ith coordinate function. Do you remember that? Yeah? Okay. That is Fi of x, y, z. Let me write x1, x2, x3, then it will be xi. Okay, but I will write in terms of x, y, z, but anyway it's okay. You understand this? Record this. Okay, now let me look at, so I want matrix T star from W star to V star. This is 3 dimension, this is 2 dimension. Therefore let us look at F1. What is T star of F1? Okay, now T star of F1 acting on vector, where should it act? It should act on vector UV, right? But this we can already found out, but you can do, I am just trying to do it again. This is by definition F1 of T of UV, and F1 of T of UV is U, V, U plus V, which is just U. You understand that? Yeah, what is F1? F1 is the first coordinate of TU, which is just U. You follow that? Yeah, therefore T star of F1, okay, acting on UV is, okay, let me call phi 1, phi 2 dual basis. Oh, maybe, right. I usually call G and W. Okay, it's okay. Now dual basis of V star, dual to epsilon 1, epsilon 2 of R2, right? Okay, therefore this is nothing other than phi 1, because it takes the vector UV and projects onto the first vector. You understand that? Clear? Pause, review, proceed. Similarly, T star of F2 of UV is F2 of T of UV, which is F2 of U, V, U plus V, which is just V, therefore it is phi 2 of UV. Therefore, T star of F2 is phi 2. Now what is T star of F3 of UV? That you can see is F3 of T of UV. I am just writing so that you get practice. Okay, the moment you see T star of something, how you should act, this you should learn. That's why I am doing all these things. I could actually derive it from this. This is going to be F3 of U, V and U plus V, but that is U plus V, but that is nothing other than F1 of UV plus F2 of, phi 1 of UV and phi 2 of UV. Therefore, T star of F3 is phi 1 plus phi 2. Yes? Yes. Hi, there was an interruption, a courier. I have to see where I have to start from. Let us just see. And just make sure everything is okay. Recording, be screen share. Okay, right. Okay, right. So now we have found out what is unit 2. Therefore, matrix of T star is going to be the column, right, of T1. T of T star of F1 is just phi 1. Therefore, it's going to be 1 and 0. Right. The next one is 0 and 1. Next one is 1 1. Right. Now just compare this with matrix of T. Matrix of T, this is a 2 by 3 matrix. This is 3 by 2 matrix. That was 1 0 1 and 0 1 1. Let me just make sure. Yeah. Do you observe anything? Anything interesting? Okay, right. So now we have some kind of an idea about how to work with T star. But let me again go back. See, I told you here, right, let us do that. Yeah, see, T star of G, I said this is this. T star of G of UV is half, this is A plus B times U and this, right? Now, I just want you to think about, that's it, don't get worked up. T star of G UV we found out is A plus C into U plus B plus C into V. I hope I am correct, right? This is for any G. What is G? G is a linear map from R3 to R. How is it given? G of XYZ is AX plus BY plus CZ, right? Now therefore what will be my F1? F1 is from R3 to R, that is G of F1 of XYZ is just A, right? It is just 1, therefore it is nothing other than my A in this case is 1. Let me write it. In this case ABC is 1 0 0 and F2 from R3 to R is where ABC is 0 1 0 and F3 from R3 to R is ABC is 0 0 1. Why am I writing all these things? Therefore what is T star of F1? You can see that A plus C, that is A is 1, C is then, therefore it is just 1. UV is nothing other than A plus 1, that is 1, B plus Z is 0, okay, 1 times U, and T star of F2 of UV, I could have simply plugged in. Do you understand that? T star of F1 is this, and T star of F2 is, for F2 it is, what is A, B, C? That is 0 1 0, therefore it is just 1 times V, and T star of F3, okay, acting on UV. Now what is that? A, B, C, this is T star of, this will be 1 and 1, therefore it's going to be C is 1, C is 1 here, therefore it is U plus V. You understood that? That's what we found out. Okay, so what we have shown is that just you try to train yourself, okay, with various things, how to look at T star of G, T star of F, etc. Okay, let us do a second example. So let us do something, suppose T is from Rn to Rn, okay, which is given as T of, let us say, x1, x2, xn is 0, x2, no, let me write x2, x3, xn and 0, right? Now T star of, let me call it V, this is also V, if you W, therefore W star to V star, right? Now start with any G in W star. Now G, that means G is a linear map from Rn to R. Then I know G is of the form G, let me say y1 to yn is, let me write G of x1 to xn is a1 x1 plus an x1, right? Therefore T star of G, I want to find out, that's going to be a linear map from Rn, the domain Rn to R. That means I have to find is what is T star of G acting on x1 to xn. This is by definition G acting on T of x1 to xn, right? But what is this? This is T, this is x2, x3, xn and 0, and this is, what is that thing? A1 times the first coordinate, A1 times x2 plus A2 times x3 plus an minus 1 times xn plus an times 0. You understood that? Therefore T star of G is this map F, where F is from Rn to R. What does it do? F of x1, x2, xn, it maps it to a1, x2, a2, x3 plus an minus 1 xn. That's it. Okay. So we found out what is T star. Okay, pause, we will proceed. But let's recall something interesting. Suppose I consider Rn as Rn complement. Okay, this is my V. Okay, W is also Rn. I will consider as Rn column vectors. And what is V star? Then V star we know is Rn with row vector, and W star with Rn with row vectors. Right? We have identified these things. Right? Therefore, now look at what is T star of from W star to B star. So you give me anything. Okay. Now how did I identify? Let's go back. If G is from Rn, that is Rnc to R, then this R be identified with a1 into an, where G of the vector x is a1 x1 plus an xn. Then this is what the identification is as a row vector. Right? Therefore this acting on a1, a2, an, now you see that that's going to be, it should act. Where does it act? Now you look at that. This is how it acts. Therefore it acts as a1, it acts as 0, a2, an. Right? Because T star of a1, a2, an must be equal to b1 to bn. Okay? And how does it act? T star of a1, an, okay, acting on some x1, xn must be same as b1, bn, acting on the column vector x1, x2, xn. Think of this column vector. Okay, but that by definition b1 x1 plus b2 x2 plus bn xn. But we know what this is. This is actually a2 x1 plus, sorry, let me just make sure, a1 x2, sorry, this is a1 x2 plus a2 x3 plus an xn, an minus 1 xn. Okay, these two are equal. That means my b1 is 0 and b2 is a1 and bn is an minus 1. Therefore T star of a1 into an becomes 0, a1, a2, an minus 1. Whereas T of x1, x2, xn was x2, xn 0. So you can see this, I can think of this, I am shifting on the right. This is a right shift, whereas this is left shift. That is, I have a1 into an, okay, and shift it to the, sorry, this is left shift. Okay, this is right shift. Right, I am shifting to the right. 0, I just put 0 and then put that. So what was the purpose of this? The purpose is very simple. Essentially, I wanted to show that if I what is the idea of identifying the dual space? Because if I think of it as a dual space, then T from Rn to Rn was, let's say, right shift or left shift, I don't remember what it is. Okay, and T star from Rn row to Rn row becomes opposite direction. Okay, this beautiful thing we can observe. That's why I wanted to do it. Otherwise, what you have done with respect to the linear maps is already good enough. Okay. Now let's prove the next result. Let us assume V, W are bidimensional vector spaces, and T is a linear map from V to W, and T star is a linear map W star to V star. Let's fix a basis V1 to Vm and W1 to Wn. These are V, these are W, and the dual basis F1 F2 Fm and G1 to Gn. This is the dual basis. Is the notation clear? V1 V2 M is a base of V, and F1 F2 Fm is a dual basis of V star, and W1 to Wn is a basis of W, and G1 G to Gn are dual basis of W star. Right? Now let A be the matrix of T with respect to the basis V1 and W, V and W, and B the matrix of T star with respect to the dual basis. And this, okay, let us assume the dimension as, okay, this is a dimension Mn, therefore this will be a matrix of size n cross m. This will be a matrix of size m cross n, because T star is from this dimension is n, and this is m, therefore it will be m cross n. You understand? So what we want to claim is, we then have, we had already observed, can you guess? Okay, and notice the size also, so you should be able to make easy guess. Okay, let us verify that. Okay, so we do not know, we will write it later. What goes here we will write later. So the problem we want to look at now, if T is a linear map from V to W, and T star is a linear, the adjoint map from W star to V star, if we fix a basis for V and W, take their dual basis, we can find the matrix of T and matrix of T star with respect to the basis and the dual basis. Okay, and we want to know what is the relation. Okay, so let us do that. So V, W are bidimensional spaces. Let us assume Vi 1 less than equal to I less than equal to M is a basis for V, and Wj 1 less than equal to J less than equal to N basis for W, and let Fi 1 less than equal to I less than equal to M dual basis for V star, and Gj 1 less than equal to J less than equal to N dual basis of W star. Right? Now let T from V to W be linear. Then matrix of T, call it A, right, with respect to the basis, the given basis. Okay, so how do you do that? You look at A of Vi, then we write it as A Ji Wj j equal to 1 to n. Okay, the ith column of A is these coefficients, namely A1i, A2i and Ani. Okay, right. Keep this in mind. Now we want to find the matrix of T star with respect to the dual basis. Call it B. And what is the size of this matrix? This matrix A is of type. Okay, so we are M to N, therefore it will be N cross M. Notice that. Okay. Yeah. So this is M cross. Is it okay? There are N rows. Yeah. Okay. And this will be. This is from T star is from where to where? W star to V star. This dimension is N. This dimension M. Therefore, this will be of type M cross N. Yeah. So we have a guess. Let's not worry about the guess. Okay. Question is, are A and B related? Okay. There is an obvious answer because based on our examples, but let's do it directly. Right? Let's look at. So let us take a GJ. So let us, T star is a map from where to where? W star to V star. So start with the basis T star GJ. Then what should I write? I should be able to write it as B and this is FR. Right? Therefore it is going to be FRJ and this is R equal to 1 to M. Right? T star of J must be in V star and these are the bases, therefore this must be the thing. Okay. Now let us understand what is T star of. So we need to find BRJ. Right? The obvious thing is very clear by now, you should know, just act on the basis. Okay. So let us act it on Vk. Notice that this is a linear function on V star and V1 to Vm is the basis for V. Therefore I want to operate on this. Therefore it is B Rj Fr R equal to 1 to M acting on Vk, but that is going to be R equal to 1 to M Vrj Fr on Vk. Okay. Therefore this is okay. This is delta Rk. Therefore the only surviving term will be when R equal to K. In that case it is Bkj. Right. So what you have found is T star of Gj acting on Vk is Bkj. Right. But we can find out the definition of T star of Gj acting on Vk by definition is Gj acting on T of Vk. Right? That is Gj acting on T of Vk is, okay, this is going to be some A, right? What do I have? A, let us say R K W R equal to 1 to N. Right? This is our way of writing. Notice that I am not writing KR. Okay? This is the way. Therefore, this is going to be summation R equal to 1 to N ARK and Gj on WR, but that is delta JR. Therefore, what do I have? R is allowed to vary, therefore that R must be J, therefore AJK. Right? Therefore, I have found out what I have found out. I have found out T star of Gj acting on Vk is AJK, but that also we know T star of Gj acting on Vk is Bkj. Right? Therefore, B equal to Bkj and okay, this is of type. Where does K run from? K is running from 1 to N. and J is running from 1 to M. I hope I am doing it correctly. Okay, yeah. B is of a type, let us see, type M cross N, therefore it should be M cross N. Yeah, 1 less than or equal to K, less than or equal to M, and 1 less than or equal to J, less than or equal to N, because K coming from Vk, and Vk is a basis of V, and the dimension of V is M, therefore it is 1. K runs from 1 to M, okay? But this matrix is nothing other than the matrix A transpose. Right? Because Bkj is nothing Akj. Right? So, so we have proved a theorem. Okay? Under stated conditions. Matrix of T star is matrix of T and take its transpose. So pause, review, proceed. So let us look at one more example. Okay, of adjoint map. This I should have done before, but I forgot. Suppose A is a matrix of, let us say, M cross N, right? Then I can consider as a map from Rn to Rn. Namely, start, if you want, think of this as a column vector, right? Therefore, A acting on X, this is a matrix multiplication. So this belongs to RMC, right? We usually call it TA of X. By definition, A times X. Now we know it's a dual is Rn R, and the dual of RMC is Rm rho, right? Therefore, my TA star, that is the adjoint of TA, that must be a map from RMR to RNR, right? I say TA star of any vector y is in RMR, okay, is nothing other than y times A. Notice that this will be 1 cross M, this will be M cross N, therefore the result will be 1 cross N, which is in Rn. Is it okay? This is a claim. Okay, right. The result is very easy. You have got to keep your ideas very clear. So how will I do that? Let us look at it. Suppose G is a linear map from, so I want to look at TA star of G. Okay, where is G? G is in Rn, Rm, C dual, right? Because TA star is a map from Rm C dual to Rn C dual. Let me just make sure. Yeah, right. Therefore start with the G here, right? Now since G is an RMC star, then this G corresponds to a unique B in RMR, B equal to B1 to Bm, such that G of y1 y2 mm is nothing other than b1 bn dot into y1 y2 ym. This is nothing other than bj yj, j equal to 1 to m. This is a matrix multiplication. Okay, it's a 1 by 1, but we always identify with the number. Is that clear? Yeah. Okay, so this is your G, right? Therefore, what I want to know therefore is, let us get. So T star of G, okay, I want to say this is identified with BA. This is what I want to claim. That is T star of G acting on any vector V in Rn, C is nothing other than BA acting on the vector V. Right? But what is this by definition? This by definition G of TV. I am writing T as TA. This is nothing other than G acting on TV is just A times V. But G acting A times V is B times A times V. Therefore, we approve this. Okay? It may look like magic. Okay? If the concepts are clear, you will be confident. Okay? And because the abstract thing is very easy to state. But if you want to look at the concrete things, you have to revise back many times. Please do that. Don't hesitate. Okay? The whole thing in dual space may be done in less than 2 hours in a typical classroom. Okay, and things will go fast, you may not realize. Please review, you will see how easy it is and how confident you become. That's more important. Okay, so if A is, think of this as, this is an M cross N, therefore it's Rn to Rm, then A star from Rm to Rn, whatever it may mean. Okay, this if you want column and row, then that is A star of any B is BA. Right, this is in a nutshell. Because of the increased use of linear algebra in machine learning, deep learning, whatever you call it, data science, etc. Okay, one has to learn to understand linear algebra, also how to turn it into matrices, because any computation will involve in terms of matrices of numbers. Okay, that is why I am emphasizing the matrix aspects of linear algebra also, but typical algebra courses may sidestep that. But if you want to help your friends in data science, deep learning, machine learning, or artificial thing, and natural language processing, all these kind of modern things, okay, you should become confident in these things. Okay, so next thing we want to prove is the following. This is a lemma. Suppose T is a linear map from B to W, therefore T star is a linear map from W star to B star. Okay, right? Now what are the things we have found? See, what we want to do is, let us look at kernel of T star. Right? I want to say, do you remember we have defined annihilators? If y is a vector subspace of V, then y purpose will be set of all f in V star such that f restricted to y is 0. So, suppose G belongs to kernel of T star. What does that mean? This means this is belongs to if only T star of G is 0. Right? But T star is a map from where to where? W star to V star. Therefore, T star of G is a map from V star to R. Therefore, this is true if only T star of G, V is 0 for all V in V. Right? But what is the definition of T star of G, V? This is G. G acting on TV is 0 for all B in B. What does that mean? This means G belongs to the annihilator of image of T. That is, if only G belongs to image of T purple. because as B varies, this constitutes the image of T, right? Okay, so pause, review, proceed. So what you have got is kernel of T star is image of T perp. Now take annihilators again. Remember spaces are all pi-dimensional. I may not have said, but these are all pi-dimensional spaces. Okay, therefore V double star is V. And we also know if Y is a vector subspace, Y perp will be Y. Do you remember? We made a fuss about what is the actual meaning of this, because this fellow lies in V double star, this fellow lies in V. So what is the relation between them? Because we are identifying V with V double star. Please go through once again, as many times as you become very comfortable. The way you multiplication table, you can rattle off quickly the same way, right? Now therefore take again annihilator. Therefore kernel of T star perp is image of T. Okay. Is it okay? Now I want to say image of T and image of T star. Right? What is image of T? This is TV. This is T star, W star. Right? Okay, now we want to say something about them. So let us look at image of T star. So dimension of image of T star, okay, is equal to dimension of W star minus dimension of kernel of T star. Right? Because T star is a linear map from W star to V star by rank nullity. We have this, right? But I know what is dimension of W star minus dimension of the kernel of T star. Okay, now what do I know kernel of T star? It is perpendicular to the image of T perp, right? Yeah, therefore this is dimension of image of T and its perp, right? Now what do I know? Image of T is a vector subspace of W, right? Therefore, and we do remember W equal dimension of W, we already have seen dimension of image of T plus dimension of image of T perp. Right? Therefore, if I use that, okay, this is equal to dimension of W star minus, okay, dimension of W, okay, yes, therefore minus dimension of image of T, right? Dimension of W minus this is dimension, right? Okay, but that is equal to dimension of W star minus dimension of W plus dimension of image of T. But we know these two are the same dimension, therefore this dimension. So what have we shown? So I have shown that dimension of image of T star equal to dimension of image of T. Right? Notice that this is nothing other than rank of T star, and this is nothing other than rank of T. Therefore what I have shown is rank of T star is same as rank of T. Right? Therefore rank of matrix of T star will be rank of matrix of T. Right? But matrix of T star is matrix of T transpose. Right? Call it A, therefore rank of A transpose equal to rank of A. So after so much of work we proved the column rank and row rank of matrix are the same, but that was not the original aim. But our original aim was to talk about dual spaces. So let us quickly summarize. What did we do? We started with the vector space V. We defined the linear functionals on them. We found the dual space we defined. Then we given a basis of V, we define what is meant by a dual basis. We looked at examples, right? Next, what did we do? We looked at the adjoint of a linear map. If T is from V to W, then we define T star to be the dual of W to dual of V, right? And again, we looked at some examples of T star, how to write down T star explicitly. After that, we looked at the matrix of T star and the matrix of T with respect to the base and the dual bases are related. Namely, one is the transpose of the other. Okay, these are the things which you have learned in this course. There are 5 lectures, 5 videos. I hope you enjoyed. But please remember, the real difficulty is you are not dealing with only vector space, which is already an abstraction. Then you are looking at V star, which is functions from V to R. Then again you are looking at functions from V to R, that is V double dual. Okay, we also identify V double dual with V if dimension V is finite. And not only that, when you want map from V star to W star to V star, that means set of functions from W to R. From that space, I want to find map it to set of functions from V to R, that is W star to V star. These are the things. So unless you go through that, every time when the object, the symbol is there, try to understand where does it belong to and what does it mean. That is the real trick of mastering dual spaces. Okay, we will meet again. Take care, stay safe.